Why we get node? Can we have a nodal point in single degree of freedom system? I might ask a question in final examination. We can get a anti-nodal point in single degree of freedom system, O or X. X, because having nodal point or anti-nodal point has to do with more than single degree of freedom system. Right? What is the anti-node? What does it mean by anti-node? Anti-node. Okay? If we draw the shape of this mode, and then it look like, for example, if I draw x1 over here, okay, x1 over here, magnitude of x1 and the magnitude of x2 over here, then the one look like this, right? Move together. And the other one look like this. So there is a nodal point. Okay, antinode occurs at this point and this point. Antinode simply means the position where we get maximum amplitude of vibration. Nodal point means that the position where we get zero displacement. Okay? So, that means in 2 degree of freedom system or 3 degree of freedom system, if all the mass moves in phase, then it's not simply possible to have a nodal point. To get the nodal point, some of the mass, at least the one mass, has to move out of phase with other mass. Why does it important to know the nodal point, the position of nodal point? Okay, if you know the nodal point, for example, when you take a ride in a ship, and you estimate the length of a ship, and then you are clever enough to estimate the bending rigidity of the ship, and then so on, and then you may quickly be able to quickly estimate where the nodal point is possible. Right? We will learn how to do it in the next few weeks. Believe it or not. Then what you can do? That means if you have a sit on that point, you would not have any vibration. Isn't it wonderful? Right? Right? So, that is a little bit, somewhat exaggerated application. But suppose you have to put a muffler. Suppose you are required, you were asked by your supervisor how you put your muffler. The muffler look like this. Silencer. Taking the gas from engine. Okay. You have to somehow put your muffler to the body of a car, right? Where you put a support of the muffler to the body at nodal point. Right? That would be a very clever way to put the muffler, attach the muffler to the car body. So, knowing the position of a nodal point has a great practical importance. Right? For example, when you design the vibrator of a hand phone, cell phone, what you want is you want to have a big vibration amplitude, right? Right? And the nodal point, where you want to have a nodal point? Nodal point has to be somewhere where you put a very sensitive instrument. For example, if you design a space shuttle, and then you know where the nodal point is, then the position of nodal point should be used to put a very sensitive instrument. Right? And the position of antinodal point, you may want to put somebody else you don't like it. Right? So, for 2 degree of freedom system or n degree of freedom system, we will have the information of vibration that has to do with spatial information. As for single degree of freedom system, we don't have a spatial information, right? Just the oscillator at here. But 2 degree of freedom system oscillate like this, or in combination. There is a spatial information, meaning that the relation between this mass's motion and this mass's motion. Therefore, modal analysis is very important, and we use this example to understand how to really do the modal analysis. And I appreciate Mr. Park's preparation. Okay. And then what we will do? We will expand this 2 degree of freedom system to n degree of this degree of freedom system. For example, I have a mass, do, and stiffness, M1, M2, etc., etc. Right? And then we can do the modal analysis. Then we can find the mode shape of this mass. First mode look like everybody go up like this. The second mode may not look like this, but has different phase. Like this. And then using that mode shape, we can estimate how that n degree of freedom system would vibrate when there is excitation force on each mass. Okay?